I'm Anil Kumar, and in this video we'll discuss conditions for horizontal asymptote and restrictions on the range of rational functions. Now, these two are very related topics. We'll do it with the help of examples. As you know, rational functions are a ratio of polynomials. I prefer to write n for numerator, polynomial in the numerator, d for denominator, right? Okay, so that is the ratio, and of course denominator cannot be 0. This leads to restrictions on what? Domain, right? So that could be two type, which is whole or vertical asymptote. Is it okay? Which we have already discussed in a different video. Now here we'll discuss about horizontal asymptotes. Now horizontal asymptotes are basically restrictions on range of the function. We'll see how. So let us consider degree of denominator and numerator. So we say let n be degree of numerator n of x, and let m be degree of denominator d of x. Is that okay? Just for easy communication. So the conditions for horizontal asymptotes are kind of like this. I'll give you with examples. If numerator degree is less than the degree of denominator, then we have a horizontal asymptote, and the equation is y equals to 0. If numerator degree is equal to the degree of denominator, then we have a horizontal asymptote whose ratio will be, ratio of leading coefficients. Of numerator and denominator. And if degree of numerator is greater than that of denominator, then we do not have horizontal asymptote. Is it okay? So these are three basic conditions. So now I'll write equations and explain this. Let's take examples. That's best, right? F of x equals to x cubed plus 2x squared minus 3 divided by x to the power of 4 plus 6. Now what is the degree of numerator? So here n is equals to 3. Degree of denominator m is equals to 4, right? You know 4 is greater, denominator is greater, condition number 1. So y equals to 0 is the horizontal asymptote. Clear? Now let's take another example. G of x equals to, let's say, x squared minus 2x plus 1 divided by 3x squared plus 3. Now in this particular case, degree of numerator is 2, right? Degree of numerator is 2, that is the highest thing, and m is also 2. Same ratios, right? Same n and m, degrees are same, and therefore we do have a horizontal asymptote, ratio of leading coefficient. So what is the leading coefficient of numerator? 1, right? And this is 3, so y equals to 1 over 3. Let's take another example where degree of numerator is higher. For example, x cubed plus 1 over x squared. Now degree of numerator is 3, right? And that of denominator is 2. So here no horizontal asymptote. Is that okay? So that is how it is very easy to find horizontal asymptotes. In most cases, I'm not saying in all, most of the time, there are exceptions, okay? Most of the time, horizontal asymptote is a restriction on range. Horizontal asymptote may be may be a restriction on range. So that is how restrictions are of range are related to horizontal asymptote, but not necessarily. Okay, let's be very clear about it. Let's be very clear about it, right? So that is important to understand. But I hope with this example you got the basics. Now you can always search for my videos, Anil Kumar Horizontal Vertical Asymptotes playlist, to get into many examples and practice those questions to be master, right? I hope you have understood the concept. Feel free to post questions, subscribe to my videos, and if you like, you should like them. Thank you and all the best.